Hello and welcome to the second part of our first lesson in our fifth unit solving quadratic equations in our grade 10 academic math class. So in our first part of this lesson we talked about quadratic relations versus quadratic equations, how they're different. Essentially the difference is that while quadratic relations have input and output values, so two variables, x's and y's, in a quadratic equation we're just looking for one particular variable that spits out a specific output value of 0. Methods for solving, and we're going to go over three of them in this unit, are the first one is rearranging and square rooting. So we're trying to isolate x such that the left side of the equation will equal the right side of the equation. We're doing that by following bedmass backwards to isolate our variables. So let's start right here. We have 9x squared minus 16 equals 0. So what's happening to x? So there's our x. It's having three things done to it. It's being squared, it's being multiplied by 9, and it's having 16 taken away from it. So we want to undo that following, as I said before, bedmass backwards. So the first thing that we are going to undo is we are going to undo subtract 16 by adding 16 to both sides. So my next line is going to look like 9x squared equals 16. Okay, so that was the a and the s. We've dealt with the addition and the subtraction. Now we're going to undo the multiplication and division. So how do we undo multiply by 9? Divide by 9. Okay, now I'm not going to type this into my calculator. Strictly speaking, we don't really need our calculators for this part of the unit anyway. So now I will have x squared equals, I'm going to leave this as 16 over 9. Now at this point I want to be square rooting both sides, which is what I'm doing. And now we have, so I ran out of space, I'm going to cheat and go kind of sideways here, which isn't great form, but it is what it is. X then is going to equal plus and minus. So remember, when you're taking the square root of a numerator and a denominator, or sorry, I guess when you're taking the square root of a fraction, you take the square root of both the numerator and the denominator. And that will give us 4 over 3. So our answer will be plus minus 4 over 3. Is it okay that it's a fraction? Absolutely. Again, these are corresponding to 2 points on a parabola where they cross the x-axis. So is it possible that they're fractions? Yeah, absolutely it is. So that fine answer, again, don't forget that plus minus. We are dealing, of course, with two solutions, not just one, at least in this case. Okay, let's jump over and tackle one more example over here. So we have x squared plus 9 equals 25. So what's happening to x at this moment? Two things. X is being squared and having 9 added to it. So I want to undo the operations following bedmass backwards. I'm going to start by subtracting 9 from both sides. So subtract 9 from both sides. That's going to give us for our next line x equals 16. And now I'm going to isolate x by, oops, it should be red, by square rooting both sides. And once I have square rooted both sides, I have x equals plus minus 4. Again, I keep saying it, I know it's important to reinforce it. That plus minus is so important because often, not always, but often we're dealing with two distinct values that are our solutions. And if we just put a plus, we're leaving one of them out totally. Okay, so what you'll notice about all of the first 5 that we've done is that they're close approximations of what you would see in like standard form versions of a quadratic relation. The one that we're going to look at next, x minus 2 all squared equals 25, this one's looking a little bit more like vertex form. So in vertex form, you've got these brackets that are happening, and you have contents inside the brackets. And that's important for us because we haven't dealt with the b yet in bedmass when we're working backwards, and that's something that we need to be mindful of. So as we're working through questions that have these brackets, remember that b is the very last thing that you do, which is going to lead us to a slightly different version of how to finish these questions. So without further ado, stop talking and get to it. So here we go. There's x. It's having 2 subtracted from it, but it's inside a bracket. So that's really a b value. And then it's being squared. So we are going to undo the squaring first because that negative or subtract 2 is happening inside a set of brackets, and we have to respect the b in bedmass and do it last. So once we've square rooted both sides, we have x minus 2 on the left, and on our right side plus minus 5. Now again, don't forget, we need that plus minus there. But now we're in an interesting position because we have x minus 2. The brackets are now gone. The process of square rooting has freed us of the brackets. But now we have sort of two scenarios to consider. Scenario 1 where we have x minus 2 would be equal to a positive 5. And a second scenario where we have x minus 2 would be equal to a negative 5. We're sort of respecting the fact that there's a plus minus here by saying, okay, so if there is a plus minus, what would happen if it was positive? What would happen if it was negative? And we need to play each of these out. So in playing these out, I'm going to continue to try to isolate x. I'm going to do that by adding 2 to both sides of my equation. So in this sort of first scenario, I now have x equals 7 as my final answer. And in my second scenario, I'm going to add 2 to both sides again. And this time, x will be equal to negative 3. So what's different about this one than the examples we did before? Well, up until now, we've had two identical answers, plus minus 5, plus minus 7. Well, no real solutions, I guess. Plus minus 4 over 3, plus minus 4. We're talking about, again, the two solutions were the same number with different signs. But once you introduce this bracket, this very last step in isolating the variable, after the square rooting, it sends you down a path that results in two different answers. Now, they're both still right. If you were to substitute 7, so if you were to take your final answer, if you were to substitute 7 into this equation up here for x, the left side would equal the right side. 7 minus 2 is 5 squared, which gives you 25. And if you were to substitute negative 3 in there, negative 3 minus 2 is minus 5 squared, which gives you 25. Both answers are still correct. It's just they don't happen to be the same number anymore, which is okay. There's no problem with that. Just a little bit of a variation on the isolating if you have to deal one with brackets. Okay, let's look at another example here. So we have x minus 2, all being squared, plus 9 equals 25. So let's figure out what's happening to our variable here. Here's our variable x. Well, it's having three things done to it. It's having 2 subtracted from it in a bracket, it's being squared, and it's having 9 added to it. So we want to undo this following bedmass backwards. Now I know some of you are going to be tempted to try to move that too. It's stuck in a bracket right now. It has to be the very last thing that we do. So that leads us to subtracting 9 from both sides. That's how we're going to start off here. So there's our minus 9. Our next line is going to look like then x minus 2 all squared equals 16. Okay, now we're going to undo the squaring. So we square root left side, we square root right side, and now we have x minus 2 on our left side, which is nice, equals plus minus 4. So again, we've got two scenarios happening here. One, where x minus 2 will equal a positive 4, and a second scenario where x minus 2 will equal negative 4. And again, I know I sound like a broken record, but I want to make sure you're hearing what I'm saying. We're setting this up to consider the two different possibilities. One where x minus 2 is equal to a positive 4, and one where x minus 2 is equal to negative 4. And now we continue to move on and isolate. So how do we do that? I'm going to add 2 to both sides. That's how the last step I'm going to do to isolate x. I'm going to be a little bit lazy and I'm going to sort of double dip and do 2 at the same time here a little bit with my red pen. In the first scenario, we have x equals 4 plus 2, which is 6. And in the second scenario, we have x equals negative 4 plus 2, which is going to be negative 2. So there are our two solutions. And again, if you were to substitute these into this original equation that we were given, all the way up here, if you were to substitute those answers in, you would find that both 6 and negative 2 would result in the left side equaling 25. All right, one more. Here we go. This is a big one. We got lots going on here. So there's our variable x. What's happening to it? It's having 2 subtracted from it inside a bracket. It's being squared, it's being multiplied by 4, and it's having 9 added to it. It's huge. As before, we're going to isolate our variable by following bedmass backwards and undoing operations that way. So again, don't be tempted. That negative 2 is stuck in a bracket. It can't be moved yet. But we can start by moving the 9. By subtracting 9 from both sides, that's going to give us 4 bracket x minus 2 all squared equals 16. The next thing we're going to undo is going to be multiply by 4, so we do that by dividing both sides by 4, and that's going to give us x minus 2 all squared equals 4. Now we're going to square root both sides, which is going to give us x minus 2 equals plus minus 2. And now we've got those two scenarios again. Scenario 1, where x minus 2 will be equal to a positive 2, and scenario number 2, where x minus 2 will be equal to negative 2. And we are going to continue to isolate our variable x. So I'm going to add 2 to both sides. I'm going to do that same little cheat because I don't want to change my pen color. I'm lazy. If we look at the first scenario, x minus 2 equals positive 2. We add 2 to both sides. X will be equal to 2 plus 2, which is 4. And in the second scenario, x minus 2 is equal to negative 2. Add 2 to both sides. X is equal to negative 2 plus 2, which is going to give us 0. So there are our two solutions. Hopefully this lesson makes sense to you. If it doesn't, by all means, go back and watch parts of it again. The homework itself, interestingly enough, is all kind of here for you. The solutions, of course, are up on the website, but I do want to point out that the answers aren't listed at the bottom. What I'd like you to do is check your solutions using substitution. So what that means is, if you end up, say in our first example here, spoiler, the answer is plus minus 5. What I would encourage you then to do is substitute back in. So our left side is equal to 200. Our right side is equal to 8x squared. And I'm going to substitute in 5. And that's going to give us 8 times 25, which is going to give us 200. So left side equals the right side, which proves that our answer is correct. However, we do have two solutions here. We have left side equals 200. Right side equals 8 times negative 5 squared, which is 8 times 25, which gives us 200. So both solutions work out, which is as it should be. Now, that's a tremendous amount of work to substitute in every time. I would say that when the answers are the same value, when you have a plus and minus 5, choose one of them to substitute in. You don't have to do both every time. But when you get down to some of these further examples where you have two different values, like over here, if you have two different values, I would recommend spending the time to substitute in both 15 and negative 5 in for x and ensuring that left side equals right side. So hopefully that makes the homework a little more clear. As I said, if you have any questions, just email me, and hopefully this goes smoothly, and we'll see you in lesson number 2.